Right. Last week we have discussed about waves. So we have completed that lesson last week. Right. We have completed the waves lesson last week. I would like to recall what we have go through in that lesson. If I split the lesson into parts, first we have discussed about mainly about the basics of waves. Right. When it comes to waves and the application. If I split the lesson, we studied like this. How we studied? First, we studied about the basics of waves. We have discussed, right? We have discussed about the basics of waves, right? Under that, we have discussed about what is called a wave, the classification of waves. We have discussed, right? The classification of waves, what are called waves, and we have discussed about the differences between those different types of waves. We have discussed. At the same time, we have discussed about the physical quantities related to waves also. We have discussed about the wavelength, frequency, period, and amplitude and all we have discussed. That's the first part of the lesson. When it comes to the second part of the lesson, we have discussed about electromagnetic spectrum, right? That's the second part. Okay. When you study this also, split like this and study, right? So when it comes to the second part of the lesson, electromagnetic spectrum, we discuss about different types of electromagnetic waves and what are the characteristics of them we have discussed. At the same time, we have discussed about what are the applications of them also under things. After that, the third part of the lesson is we have discussed about sound waves, right? We have discussed about sound waves. Under that, we discussed which type of wave is sound wave and the speed of sound waves and all depend on the medium. At the same time, we discuss what happened to the speed of sound when it comes to the temperature difference. And we discuss what else have we discussed about? We have discussed about the characteristics related to sound waves, pitch, after that loudness and quality of sound. We have discussed about them, and the physical quantities related to those characteristics of sound waves also we have discussed under that. After that, we discuss about musical instruments and their the factors affecting their frequency and their examples and all we have discussed. If I recall the lesson, these are the three main parts we have discussed throughout the lesson. Okay, right. So here, as we have finished the lesson, I would like to discuss some past paper questions they have asked on this. Right. Today I'm going to do 2016 all-level papers. There are some questions they have given in a structured paper. Right. I'll be discussing that, which is on waves. Right. Okay. We'll start. I'll be sharing here the paper. Right. We'll see what they're asking. Right. In 2016 all-level paper, here they have given this question in the structured part in Science 2. Question number 4 they have given on this. Right. We'll read the question first and we'll try to answer. Right. Okay. Here, what they're asking. What they say. Consider the following types of waves. They have given a bunch of waves, right? We'll see what are they. Ultraviolet rays are there. Infrared rays are there. Microwaves, X-rays, gamma rays, visible light, sound waves and ultrasound waves are there, right? These are the types of waves they have given. On these, they are asking questions from, right? We'll see what they ask. Of the above waves, mention a wave that propagate with compressions and rarefactions. Right. So they're asking, they're talking about compressions and rarefactions. Can you remember which type of waves travel like that? Which type of waves travel like that? Making compressions and rarefactions.
So sound
Sorry?
waves?
Yeah, the answer should be sound waves. So if I recall that, when it comes to mainly we can divide the waves into two categories. The first type is mechanical waves are there. At the same time, electromagnetic waves are there. Why do we divide like this? The criteria behind that is we consider if a wave requires a medium, either solid, liquid or gaseous medium, we say that type of waves as a mechanical wave, right? So then at the same time, we are calling if a wave does not require any medium to propel through, that means solid, liquid, gases, even though there's a medium or not, that means those waves which can travel through vacuum, right? Those are known as electromagnetic waves. After that, again, we divide mechanical waves into two categories. No? Transverse waves are there, longitudinal waves are there. If you can remember, when it comes to transverse waves, you can identify crest and troughs. Like this, they move on, right? Like this only, making crest and troughs only, they'll be propagated, right? At the same time, when it comes to longitudinal waves, if you can remember, there's a region where the pressure is higher, all the particles are close to each other. We call that region as compression. After that, we can identify a rarefaction where the pressure is low. At the same time, particles are apart from each other. Again, a compression where the pressure is high. Again, rarefaction. That's how exactly longitudinal waves propagate from one place to another, right? Under longitudinal waves, we have discussed sound waves come under that. Okay, right. According to this question, then the answer should be, there are two answers exactly. You can write one of them. Here, if you consider, you see what they're asking, of the above waves, mention a wave that propagate with compressions and rarefactions. No? So obviously it's supposed to be a longitudinal wave. One by one we'll remove. When it comes to ultraviolet rays are, what are they? They are electromagnetic, infrared, electromagnetic, micro, electromagnetic. X-rays also electromagnetic. Gamma, electromagnetic. Visible light, yes, electromagnetic. Sound waves, longitudinal, mechanical, and we can consider longitudinal also. Ultrasound also like that. Ultrasound means only difference is they are also a type of sound waves. The only difference is when it comes to ultrasound waves, they have a frequency greater than 20,000 hertz. That's the only difference. So here they are asking what mention a wave that propagates with compressions and rarefactions. So answer has to be either sound waves or ultrasound waves. You can write. If you say sound waves, you can write no issue, right? Okay, then the answer has to be here sound waves, right? Okay, then we are moving on to question number 2. Write down a special characteristic of ultrasound waves. I already discussed about that like 2 minutes ago, right? When it comes to sound, it's another type of sound wave. If you consider about a special characteristic, so they're asking about that frequency. Their frequencies greater than 20,000 hertz, right? That's the special characteristic of ultrasound waves. Is it clear? Right, take it down. Hurry up. If you're done, we can move on to question number 3. In the field of medicine, which type of above waves is generally used to observe the condition of the fetus inside the womb of a pregnant mother? What does it mean by fetus? You study about this in reproduction system in grade 10, right? When it comes to fetus, that means like it's an unborn baby, right? Unborn baby, like unborn human, we can say, which is more than like 8 weeks, passed after the conception. We call it a fetus, right? After the conception, after 8 weeks, we call it a fetus, an unborn babe, right? Inside the womb of the pregnant mother, right? We know that they're asking now, they're asking the type of wave we are using there to consider about the condition of the fetus, right? You know that we are doing for that ultrasound scanning, right? So obviously we know the answer should be ultrasound waves. I would like to recall the knowledge here. What are the other uses of ultrasound waves here? When it comes to the medical purposes, we are using sonography. In that only, we are using this method, we are applying this application to examine a baby in pregnancy, to examine internal damage organs also. We can say another application of ultrasound waves. At the same time, by sonar systems, we can find the depth of sea. At the same time, to find voids in aeroplanes and ship bodies also, we are using ultrasound waves. We have discussed about this during the class, right here. This is how they are doing, using the sonography, using ultrasound waves is how they are doing ultrasound scanning. And here to find, using the sonar system, they are using sonar system to find the depth of sea, right? At the same time, they can use that for catch some fish species and all also, right, by the fishermen. These are the uses of ultrasound waves then, right? Okay, then answer should be ultrasound waves for question number 3. Here question number 4 is on electromagnetic spectrum. Okay, we'll read it out. A part of the electromagnetic spectrum is given below, right? If you can remember, when I was discussing the electromagnetic spectrum, I told you that you should know in the right order from left to right. If you are drawing, if the frequency increases from left to right, you should know the right order. At the same time, you know that from left to right, if you are drawing in that way, lambda will decrease, no? Starting from radio waves, after that microwaves, then infrared, then visible light, then UV, ultraviolet, after that X-rays, then gamma rays. That's how it goes on. right? They have given a part of that, but we have to carefully look at this and we have to fill them, right? A, B, C. If you write here A straight away radio waves, that's wrong. If A is radio waves, B is supposed to be micro, and third one supposed to be infrared. No, it is not visible light. So we'll start from, first of all, we'll fill C. We can easily fill C, that is X-rays, right? They have given up here, no? The types of waves, right? We have to use them and fill it up, right? C should be X-rays, right? Then B, we are moving from right to left now, right? Visible light. After the visible light, who's the neighbor of the visible light? Who's that? It has to be infrared, no? B has to be infrared, right? After that, A is supposed to be what? A has to be microwaves. It's not radio, right? They haven't given radio waves here. So we have to carefully look at that and fill it up, right? They try to make us, put us to the trouble because we are in a kind of a stress situation in the exam. So by the way, we have to control the situation, right? We have to adapt to the question and do, right? They won't start from the radio waves always, right? They can give a question like that, okay? Right, considering the sequence of the above waves, write down the types of waves that should be in the places A, B, and C. A has to be what? It has to be, as I told you, it should be microwaves. B has to be infrared, and C has to be X-rays. Right, that's how it goes. Okay. Right, we are moving on to then part B of that. Carefully read, right? Very important, each and every word. Right, a waveform relevant to gamma rays is given below. Right, they have given what we can see on the oscilloscope, right? Waveform they have given of what? Of gamma rays they have given. Right, by which name the point R of the wave can be identified. I told you that now it will be like kind of a confusion for you that how we can draw electromagnetic waves like transverse waves. I told you that the nature of the electromagnetic waves also, the waveform also similar to transverse waves. So we can identify crest and troughs, no doubt about that. We discussed about that. It's not new for us, right? We have discussed about. So then they're asking, what do you call the point R? Those points they have named as P and Q. We call them as what? We call them here.
Amplitude.
These are crest, right? These are crest. You see, P is a crest, at the same time Q also a crest. If you consider about R is a trough, right? That is a trough. Okay, write the answer for the first one. Right, the answer should be a trough. Which physical quantity of the wave is equal to the distance between points P and Q? All right, if you can remember the distance between two troughs here, P and Q, two troughs or two crests, we call it what? We call it, what do you call it? What do you call it? We call it lambda. Lambda wavelength, right? We call it lambda wavelength it is, right? So then answer should be from P to Q, the distance we call as lambda or wavelength, right? Okay, then we are moving on to the next one. Question number 3, we'll see what they are asking. Considering the features of the waveform given above for gamma rays, okay, we had to consider the features of the waveform given above for gamma rays. Draw a typical waveform in the following grid for the type of waves represented by C in the spectrum above when the amplitudes are equal. All right, we have to draw a waveform now, right? Considering the waveform given above for gamma rays, we have to draw the wave represented by C in the spectrum. Yes, what is it? It is X-rays here. This question is connected, right? Okay, one whole question. So then C means X-rays. We have to draw a waveform for X-rays, typical waveform we have to draw. So that means exactly shape has to be this. That's exactly the idea. And they say amplitudes are equal. Okay, amplitudes are equal. By the way, if you consider the electromagnetic spectrum, when it comes to X-rays, right after the X-rays towards the right side, no, gamma rays are there. We know that gamma rays has a greater energy and greater frequency also than X-rays. At the same time, lambda will be lesser for gamma compared to X-rays. We have discussed about that. Okay, right, we have to take that to your head and we have to draw. You are not just drawing. Now we have to carefully see. Shall I draw on this itself? Then it will be easy for me. Right, you have to look at this, and here they have drawn this on a graph paper. No? You can count the number of squares and you can draw easy. what you have to do exactly? We have to count the number of complete cycles here, right? If you consider complete cycles, the number of complete cycles here, how many are there? 1, 2, 3, 4, 4.5. If they have drawn this for 1 second, we can say the frequency is 4.5 hertz. Now what we have to draw? Now we have to draw for X-rays. Then anyway, we are going to draw for 1 second, we'll assume and draw, right? So then obviously the frequency should be lesser than this. So then number of complete cycles it should complete up to here should be less than 4.5. Here when it comes to the gamma rays, 4.5 there, right? So when it comes to X-rays, it should be less than that, because the frequency of X-rays less than gamma rays. And they said another thing, they said amplitudes are same. So then amplitude from here to here, now we call it amplitude, right? I'll use another color, right? From here to here we call amplitude, right? From the neutral position to the crest, no? The height of that, right? We call as the amplitude. So when it comes to amplitude, it has to be same. So when you are drawing, so carefully you have to draw. How we are going to draw now? I'll draw and show. I'm going to roughly draw, right? Because I'm doing on this screening, no? Right? So then I'm doing on the screen itself, so I can't draw properly. By the way, I'll try my best. Anyway, what you have to take to head when you're drawing, amplitude should be same. At the same time, frequency should be lesser of X-rays. So the number of cycles here, should be less than 4.5. Right, we'll draw and see. Right, so we had to draw like this, somewhat. Here, right. Okay. See with you. My amplitudes are same as the gamma rays. By the way, I have drawn how many cycles? 1, 2, 3. Only 3 cycles I have drawn. So then obviously for that black color waveform, or what I have drawn for X-rays, the frequency is lesser compared to gamma rays. You have to take that in your head and you have to draw, right? Carefully we have to do that. We have to understand what they say. They talked about X-rays. So then straight away should come to your head that frequency should be lesser compared to gamma rays. So then the number of cycles should be lesser, but amplitude is same, they say. So we have to take that in your head also, and you have to draw. Okay, right, that's how we draw. Okay, hurry up, take it down. Whether you know how to consider a complete cycle and number of complete cycles in unit time we call as a frequency and all, they are checking thoroughly. Very good question, right? So then you can expect for your exams in 2021, no, now it will be 2022 anyway. So for that exam also we can expect similar type of question, because after 2016, 2017, 18, 19, 20, 21 is here, you know. So up to here, they haven't given any question on waves like this. So we can expect they could give a question like this year, after like 5 years, right? Could be highly possible, right? So we have to expect that, and we have to go to the exam, right? Okay, then. Is it done, children? Shall we move to the next one?
Yes.
Okay, right. Now here we have done question number 3. We are moving on to question number 4 now. Of the 6 waves given in the electromagnetic spectrum above, which waves has the highest frequency? Gamma rays, no? That is pretty straightforward, no? Gamma rays, the answer should be. Okay then, that one done. We are moving on to question number 5. A diagram depicting 2 instances P and Q of an activity done in the laboratory to study a certain characteristics of sound waves. Okay. A hacksaw blade is kept on the table and a heavy metal block is kept on the blade when this activity was done as shown in the figure. Then the blade was vibrated. They have kept some heavy metal block here, you see, and they have kept that heavy metal block on the hacksaw blade, right? When you are giving a small vibration to that hacksaw blade, what will happen? It will start moving like this, right? It will start oscillating like this, right? That's exactly happened, right? This experiment we are doing in the school laboratory, right? This experiment is in your textbook also. If you go through thoroughly, right? We have discussed. We have not completely discussed during the class, but somewhat we have discussed about this. Now we have to understand what happened exactly here. If you consider Wait, I'll turn on my camera. 1 second. Right, you understand here, they have one of the short hacksaw blades here. They have a short hacksaw blade here, like this. At the same time, they have from here, they have kept that metal block, right? Okay, they have kept the metal block here. At the same time, we can draw the lengthy one also, lengthy hacksaw blade like this. Now, what we have to understand, we are giving some small vibration like this, then it will start moving, no? It will start oscillating. If you consider the short one, it can complete one complete oscillation like this. It will go, it will come back like this, and it will come back like this. Then it can complete one complete cycle. Am I right? Like this, it will move, and again it will come down like this, and again it will move up to here. Right? Then it can complete one complete wave. When I draw here, it should be drawing here. I have to draw. Like this is not here. This is how it will complete one complete oscillation. Right? Okay. If you consider this, it's supposed to go as it's lengthy. It's supposed to move further like this and will come back like this. And again it will come back like this. It will take more time, right, to complete one complete oscillation. You understand? Did you understand that? Did you understand? If you consider about the short hacksaw blade, it will take small period of time to complete one oscillation. But if you consider about the lengthy one, it takes more time, right? Will go up and will come down, and it's because it's lengthy. Then you understand, compared to this will take more time to complete one oscillation. What does it mean exactly? The idea to complete one complete oscillation, it will take more time, right? If you consider unit time, the number of oscillation completed by this, in unit time, number of oscillation completed. If you consider 1 second, this hacksaw blade will complete about, like, we'll say 3-4 oscillations like this. What can you say about this? Obviously, if this completed in 1 second 3-4 oscillations, but this won't complete 3-4. It will complete like 2 or 1.5 for sure. Am I right? Because it takes more time to move up and come down to complete one of the oscillations. Am I right? You understand what I say? It's a practical thing. Even though you have no clue about this, if you can't remember even whether you have done a practical on this, you have to look at this and somehow you should think. That's how you should, like, you should be like that, because grade 11 students who are studying science, I mean, this is physics, it's a practical subject, so obviously you should understand. So then we have to look at it again. We should be able to understand what's happening there, right? What happened here? In unit time, it will complete more number of complete oscillations compared to this. So obviously, frequency of this is greater, right? Frequency of this is greater compared to this, right? If you consider here F1, if you consider the frequency here F2, so obviously F1 is greater than F2. That's what exactly we have to understand, right? If you understand this, that's easy for you, I mean, to go through the lesson. I mean, not the lesson exactly, to go through the question what they have given, right? So then that's what exactly you have to understand. You have to understand, they're checking the understanding of frequency, right? You need time. If you're giving a small vibration like this, will move up and down, up and down, up and down. It will come here like for 1 second, it will complete 4 or 5 oscillations. But if you consider about this guy, it's lengthy, it will take more time to complete one oscillation. So in unit time, it might complete one oscillation or 1.5 or 2, something like that. Anyway, should be lesser than this, right? That's pretty no-brainer. We can understand, right? So F1 is greater than F2, right? Okay. Now we'll see what they ask. All right, we'll see. What they're asking. Which characteristics of sound wave can be studied from this activity? They're asking the first one. Characteristics of sound, no? So then it's supposed to be pitch, right? Not the frequency. If they're asking the physical quantity related to that, we can write frequency. No issue with that. They're asking the first part. characteristics of sound, right? So it has to be either pitch, or else it has to be loudness, or else it has to be quality of sound. Out of them, the answer should be pitch, right? Because they are talking about something related to frequency, no? So obviously it has to be pitch. You know that if you can remember, when it comes to pitch, we have to consider about the frequency. If you consider about the loudness, we have to consider about the energy it carries or amplitude. If you consider about the quality of sound, we have to consider waveform, the shape of the wave, right? Okay, then. So then for A, carefully do right here. They're asking the characteristic of sound, so it should be either pitch, loudness, or else the quality of sound. The answer should be pitch here, right? D, on which physical quantity does the characteristic you mentioned A above depend? It depends on, frequency, right? We are talking about pitch, no? What conclusion can be arrived at through this activity? What's the conclusion you can come to at the end of this experiment? What should be? Or else you can talk about the wavelength also. Where the wavelength is greater, frequency is obviously lesser, right? That's exactly happened when it comes to Q. It's better, I think. Rather than talking about the amplitude, we better talk about the wavelength, right? So then you can come to a conclusion where the wavelength is greater, frequency is lesser, right? That's how we can, that's the conclusion you can come at the end of this activity, right? Okay, right. I saw in the marking scheme, they had given that, when the length of the hacksaw blade increases, frequency decreases. That also correct, right? Or else you can talk in kind of like, using wavelength and frequency, so you can talk about that. By the way, I saw that they have given marks when the length of the hacksaw blade increases, wavelength decreases. That also correct, they say, right? Okay, then we are moving on to question number 6. All right, we know that they're talking about the speed of sound. How does the speed of sound in air vary with the temperature? We know that we have already discussed about this. The speed of sound waves depend on two things. No? First thing is the medium it goes through, either solid, liquid, or gaseous. When it comes to solid medium, it travels really faster compared to liquid and gaseous mediums. The reason behind that is when the particles are close to each other, they can vibrate vigorously at the same time. It can propagate. The wave can propagate really faster throughout that because the particles of that really close to each other, packed when it comes to solid. Liquid is compared to that kind of, relaxed and kind of, there are some blends you can identify between each particle. So then it has a lesser speed compared to solid when it comes to sound waves. When it comes to gaseous, particles are really apart from each other, so it is really slow compared to solids and liquid medium when it comes to the speed of sound waves, right? So if I take in values like 330 when it comes to the speed of sound in gaseous medium, if I come to the liquid, it is around like 1400, 1500. If you consider about solid, it is roughly 5000 something like that, right? 5000 meters a second, right? Okay, then that's it. Now they are asking about temperature, by the way. Here we have discussed about that also. When it comes to the temperature, how the speed of sound changes, temperature increases means the oscillation of the particles in the medium really fast, right? We have supplied heat. Because of that, when you're supplying heat, the temperature increases. At that time, what will happen? The speed of sound will increase. That is why when it comes to like in 20 degrees, 25 degrees, if we consider 330 meters a second speed when it comes sound waves, but when it comes to 50 degrees or something like that, some high temperature value, we can identify their speed of sound is greater than that, like 350, 360 could be, right? So when it comes to, they're asking what happened to the speed of sound with the temperature, the answer should be yes, they're asking that, right? How does the speed of sound in air vary with the temperature? When the temperature increases, speed of sound also increases. That's how you have to write. Okay. From here, that question is done. Today we have done 2016 all-level partial question, which is on waves. Right.